Yeah. It is 7:21. Technically, I'm back live for so far, the 0 people that are in the live stream, but they should be joining us soon, as I typically do have a good audience showing up for that. That would be great and wonderful. Moving forward, I think I told you guys the senior exam schedule, but something occurred to me that I hadn't talked to you guys about yet. So just in case I haven't mentioned the senior exam schedule, and I am going to move the camera over a little bit so the people in the live chat can eventually see the calendar right there. But they came out with the senior exam schedule, and you guys in discrete math will be taking your exam with the senior exams, because obviously we have mostly seniors. And you be taking it on Monday, June 7th. And the thing that occurred to me that was really interesting, we're taking our senior exam on Monday, June 7th, but then I have you guys again on that Wednesday for a half day, and I have you guys again on that Friday for a full day. But it's like, well, once we take our final exam, we're done, basically. So it's like, but we still technically have to show up on Wednesday the 9th and Friday the 11th. So I've been thinking about what to do about those dates. So this is kind of what I've kind of formulated in my head. First of all, these 2 days are gone. There we go. I have you today. I have you Friday. And then next week, I only have you on Tuesday because it's a 3-day week. And then the following week, the following week, the beginning of June, I would have you on that Tuesday, Thursday. Now, that Tuesday, Thursday is what I plan on reviewing for the final exam. I plan on reviewing for the final exam the 1st and the 3rd. So we have 3 class periods to wrap up the unit that we are currently working on with sequences and series. And then we take our final exam on the 7th. And then on the 9th and the 11th, like I said, I'm not teaching anything new. We've already taken our final exam. I would pretty much use the 9th and 11th as maybe a makeup time or something like that. Yeah.
So if we don't have a 3B and a 4B, do we have to come?
For example, during the week of the 7th?
Yeah.
I don't know.
Because I only have first 2 periods, and then I leave after second period.
So you're talking the 10th and the 11th?
Yeah, but I need to come because I technically don't have a class, so there would be nowhere for me to be.
Well, technically, these are regular school days. So even though we take our exam on Monday the 7th, and then on that Friday, clearly we're not taking an exam, but there would still be a 1A, 2A class period that you would have to go to. Yes, like normal, But then, this wouldn't affect you, but this would be seniors wouldn't have to attend any of this anyway because they'd be doing graduation practice and whatever. You can't.
We have graduation practice. We have Six Flags. We
Yeah.
have your picnic.
So you guys would be you'd be done at this point. I wouldn't even see the seniors during that week.
Yeah, especially the 15th.
Yeah.
We have that's our senior trip to Great Adventure, so we're going from 8:30 to 10.
At night?
Yeah.
Nice. That's crazy. I took my 8th grade trip was to Great Adventure. Yeah. I don't know. It's sad that you guys don't get to do because I know years ago Barnegat used to do the Disney trip, but obviously it can be a bit of a hassle to do that. Not to mention the travel restrictions, and all that other stuff. Yeah. I'll tell you guys a small secret. You want to know something? Over spring break, I went to Disney World. So okay, all right, yeah, whatever. No, but I was fully vaccinated beforehand. My family, my wife and my kids, they had to quarantine, but I was fully vaccinated. And New Jersey adopted a new policy that basically said that if you were fully vaccinated, you did not have to quarantine, which is why I was allowed to come back and high five people or something. But anyway, I digress. Okay, yeah, that's the schedule. It's gonna be weird. Anyway, I will, of course, have a live stream for those days. For the actual final exam day, this is weird. Now, obviously, Nicole, this doesn't affect you. Patrick, I'm assuming it affects you and whoever else is not a senior. But on the actual final exam day, which is like Tuesday, June 15th, I mean, clearly, I don't have a final exam to give you. But I will still have to take some form of an attendance. Oh, this is crazy! I just realized this. Congratulations, Patrick. You are the only non-senior. So, yay! But everyone, the seniors, of course, would be excused during that time. So, yay! Happy days. Anyway, for those of you in the chat, if you have not left a comment already, I do see the one comment that has been left so far. That would be absolutely wonderful. Here's my goal for today. Now, keep in mind, you guys all know this is a half day, right? Wednesday half days. Yay. I don't know. Ooh, did you also hear this doesn't affect you because you're going to be graduating, but like, did you hear the executive order for next year?
Yeah, you told us yesterday.
Oh, I did?
Yeah.
Oh, that's like all in person, no online. Sweet. I forgot I told you guys that. Yeah. I'm so excited. But anyway, if you do not already have them out, I'm going to need those notebooks out and open. Let's see how it goes. All right. I'm also going to be posting in the Google Classroom. Actually, so I would suggest, I mean, you already have the Chromebook ready to go, but like, if you do have the ability to access Google Classroom right now, that would be fantastic because there is a PDF that I just posted a moment ago, a PDF which contains some of the practice problems that I would like to accomplish today. And we'll kind of see how this goes. I want to put this thing together. So here are my notes, and I'll give you my opening spiel after I put a title on here. Today is the 19th, and this is, I'm going to call this, I don't know what I'm going to call this. I'll call this Arithmetic Geometric Continued. Geometric Continued. There we go. I'll zoom in on that. Okay. Here's my little spiel for what I want you guys to be thinking of. I like puzzles. I am a fan of puzzles. Puzzles can sometimes frustrate me. But when it comes to puzzles, I mean, like Rubik's Cube puzzles, I'm a huge fan of those puzzles. I think, like, I even have somewhere back here. Hold on, I'll see if I can find it. There it is, yes. I'll show people on the live stream, too. Like, I have one of these puzzles. I don't know if you've ever seen these before. But it's like, these are the type of puzzles where it's like, there's a bunch of, like, moving pieces that can come out of it. And you can take the whole thing apart. And then the puzzle is basically, well, how do you put it back together? Kind of thing. And then when you do, it's like, oh, that's pretty solid. But then once you start removing like pieces, it's like, ooh, wait a minute, then the whole thing ends up falling apart. Like, I love puzzles like this. This unit with arithmetic and geometric series and sequences, it's one giant puzzle. That's all that it really is, in my opinion. It's a giant puzzle. It's a treasure hunt. It's okay. What pieces do we need to complete the puzzle? You guys ever seen National Treasure? No? Never seen National Treasure? Nick Cage? Such a good movie. It's the most ridiculous movie you ever seen in your entire life. It's basically like a Michael Bay action film for nerds. It's like, here's a bunch of puzzles that he is trying to solve. And basically, it leads him to finding a treasure map on the back of the Declaration of Independence. It is ridiculous, but I like it. It's fun because a lot of those puzzles that he discovers in the movie, like, not that they actually exist in real life, but the concept behind those puzzles do exist. With these problems, with these arithmetic or geometric problems, it's nothing more than a puzzle. What are the pieces that they give you? What are the pieces that you need in order to get the answer? It's a huge treasure hunt. It's like, I don't know, that's what I really liked. Oh, there we go. Sydney says she loves National Treasure. Good for you, Sydney. Actually, we haven't watched it in cryptology, but it's one of my goals for this year in cryptology is to watch National Treasure, but that's neither here nor there. I love puzzles. And when I see a math problem, I consider it to be a big old puzzle. So, from the worksheet that I gave you, I am going to be picking out various problems. But I'm going to remind you of a few formulas that we may or may not need to use at various times. So I'm going to write these down again for the sake of argument. I'm going to split my page into arithmetic and geometric, because these are the two main types of sequences that we are going to be dealing with. When it comes to arithmetic, the other day I showed you this general rule for finding any term within the sequence. I showed you that general rule, and I'm writing it down again because it's a very good idea. Like if you want to learn how to use something, to be able to write it down and be like, oh, I'm going to be using this. Let me write it down and get familiar with the structure of how this thing is made. But for a geometric, it looked like this. Similar. It still has this little n-1 situation going on here, except now for geometric, the n-1 is in the exponent. It still has that a sub 1 thing going on, a sub 1 representing the first term, but regardless, this is the formula for getting any term within the geometric sequence. But then I gave you two other formulas. Actually, technically, I gave you three, but I'm going to focus on two of them today. For the sum of an arithmetic, we talked a little bit about this the other day, that letter S, that sum is a summation formula, technically. Something that people do in like calculus and whatnot with the summation formula, sigma, but I'm not going to get into those details right now. But the calculation for the sum of an arithmetic sequence would be the following calculation. Now I'm going to go into the details of this, what a sub 1 is and what a sub n is, but we're going to get into those details. And then the sum of a geometric is equal to the following calculation. Obviously, utilizing our calculators correctly, utilizing the order of operations correctly is in our best interest, because these formulas can be daunting if they are used improperly. But these are the tools for solving the puzzles. When you were a kid, can you remember the largest jigsaw puzzle that you ever did? Because when I was a kid, I did a 1,000-piece puzzle, and I thought that was a huge deal. And I realized, oh wait, 1,000-piece puzzles are really, today, they're like not huge deals. I don't know. I like them though. Like, I like the weird puzzles where it's like half sky and you have to put together a bunch of blue pieces that don't look like they match each other. I love that. So when you're faced with these problems, these are the tools that are going to help you solve those puzzles. Determine whether or not the sequence or series that you're given is arithmetic or geometric. Determine what pieces of information they have given you. Determine what pieces of information you need. And then ultimately try to answer the question that they pose. Like, I don't know. It's exciting to me to do that kind of stuff because it's like, I don't know, besting a challenge almost. And some of these can be a little bit of a challenge, but we'll see what happens. But these are the 4 tools that we are going to be focusing on today. These 4 particular formulas. And again, like I said, when it comes to an assessment, when it comes to, let's say, even your final exam, I would give these to you. I would flat out give these to you. You don't have to memorize them. I mean, personally, I have because I'm a weirdo, but you don't have to memorize these formulas. They would be given to you. Okay. So I'm on the worksheet. Again, this PDF was posted into the Google Classroom. This PDF was posted into the Google Classroom. And I want to start off a little simple, and then I want to kind of build from there. So the first thing that I want to do, I would like to knock out number 11. I would like to knock out number 11. So if you want to write down the information that they give you for number 11 on that 11.2 side, I'm going to label my notes right here. This is 11.2, number 11. They want you to find a rule for the nth term. I'm not going to write down the rest of it. Just write a rule for the nth term where they give you d is equal to 5 and a sub 1 is equal to negative 9. And that's all the information that they give you. Now, a couple of things to this. Number 1, hopefully we should be able to recognize this as an arithmetic sequence, despite the fact that they told us it was arithmetic in the directions. They said write a rule for the nth term of the arithmetic sequence. Regardless, this is an arithmetic sequence. And the way that I know that, the way that I recognize that, is the fact that they told me that d was equal to 5. If there is a d, if there is something that they call a common difference, then this is most definitely an arithmetic sequence. A sequence where the same addition or subtraction happens every time. In this case, it's plus 5, plus 5, plus 5, plus 5 for every term in that sequence. Frozen, unfrozen. There we go. Now, in reality, the only 2 things that you actually need to solve this problem is the common difference and the first term. So the only thing you really have to worry about is this. I'm going to use the formula that I gave you for the arithmetic term where I plug in the following information. Now, I have to simplify that, but let me just let that sit for a moment. In the arithmetic formula that I gave you, it was a sub n equals the first term plus n minus 1 in parentheses times the common difference, which in this case was just 5. They gave you both pieces of that information. Plug them in and simplify, and that should automatically give you the answer they're looking for. I'm going to have to distribute that 5, yes. It's going to give me negative 9 plus 5n minus 5. I'm going to have to simplify that a little bit farther until ultimately I get 5n minus 14. This is the rule for the nth term. Meaning, with this rule, I can get any term in the sequence that I want. Any. Doesn't matter what it is. I could take any number like, I don't know, like, well, for example, a 1, which we already know what the first term is, but I'm just going to throw this in here. If I throw a 1 in for that n, it'd be 5 times 1 minus 14, which is negative 9. And yes, we already knew that. But if I wanted to get the second term, I could do, well, one of 2 things, technically. If I wanted the second term in this sequence, starts with a negative 9, and then you add 5, and then you add 5. Well, there's the second term right there. Or I could take this 2, plug it in, and it would calculate out that -4. This general rule is incredibly helpful because it can get any term in the sequence, any term whatsoever. And you're going to see that on a future problem today. You're going to see that on a future problem where we're going to need that general rule before we actually get to the final answer. But what I have circled here, that's the rule, that's the answer for this problem. Let's try a slightly different one. Let's try number 12. Same exact page. Number 12, same directions. Find rule for nth term. Same exact directions. But they give you different information. Now they're giving you d is equal to 2. But a sub 12 is equal to 18. That's a mess up that I drew right there, but that's an 18. Well, I don't need the 12th term. I need the first term. I don't need the 12th term. Crap. There's a couple ways of handling this. There's a couple of strategies for handling this problem. There's one that I would recommend more than anything, but one of those strategies actually is a little bit of common sense. The common difference is 2, meaning that they would add 2, add 2, add 2, add 2, add 2 every time. And if the 12th term is 18, Mr. Markey, couldn't I logically just then go, subtract 2, subtract 2, subtract 2, subtract 2 until I got back to the first term? Yes, you can. You absolutely can. That's one strategy that you can absolutely do. And yes, it will absolutely work. But sometimes that strategy that I just described is not feasible. You can totally do that if you wanted to, but sometimes it's not feasible. A better strategy would be this. A better strategy would be what I am about to show you. A sub n equals a sub 1 plus parentheses n minus 1 times d. Using this is a much better strategy for finding the first term. In order to actually get the rule, you need the difference and you need the first term. We don't have the first term. So instead, I can do something like this. Look what I just did. Look at the heck what I just did. For instead of a sub n right here, instead of a sub n where I'm pointing the pen at, I plugged in a 12 for that n value. And when I plugged in a 12 for that n value, I also plugged in a 12 for this n value over here. And that makes sense. For the d, I just replaced it with a 2 because, well, they told me what d was. But I can solve this. I can solve this sucker because I know what a sub 12 actually is. I know that a sub 12 is actually equal to 18. And because of that, I can now do this. 18 equals a sub 1 plus, I'm going to simplify that. 12 minus 1 is 11 times 20 or times 2 is 22. And I can get a sub 1 by itself. A sub 1 equals -4. Now, yes, I could have totally gotten that by doing this. I could have totally gotten that by doing this. Okay, that's the 12th term, 18. 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay. 16, 14, 12, 10, 8, 6, 4, 2, 0, -2, -4. There's my first term. You could have totally done it that way. Absolutely, yes, you can. Except it's not always practical to do it that way. It is not always practical to do it that way because sometimes you may be sitting there forever trying to count backwards. Instead, utilizing this formula is in your best interest. I know what a sub 12 is. I can plug in that 12 for n where it's supposed to go and actually simplify that, and I can solve for a sub 1 in one fell swoop instead of having to count backwards like I just did on the board right here. That's a lot of counting. Take a shortcut. Take a shortcut. It's amazing. Now, I'm not done with the problem yet. I still actually have to solve for the nth, or the rule for the nth term. But now that I have my first term and my d, which they gave me, now that I have those two pieces of information, I can just simply do this. I know my first term, and I know my d. I'm going to distribute, and I'm going to get, oh, I know what d is. It was a 2. I don't know why I wrote a d there. There we go. Plus 2n minus 2. And now I get my general rule. Now I get my general rule. In a moment, I'm going to compare these two problems. In a moment, I'm going to compare what I did for number 11 versus what I did for number 12. Because clearly there is a marked difference here. Let me slide down number 11. Here's number 11. That's all that I had to do for number 11. They gave me the common difference. They gave me the first term. I plugged in the information, and all I had to do was simplify to get my answer. That's all that I had to do for that problem. Whereas for number 12, they didn't give me the first term. They didn't give me that piece of the puzzle. So the first thing that I have to do is I have to search out what is the first term. And once I have that first term, then I can proceed with what I wanted to do to get that rule, which was the answer to the problem. It's a treasure hunt. It's a scavenger hunt, so to speak. You have to collect the right pieces in order to unlock the answer. They don't always give you the right pieces, but you can seek out those pieces. Let me do one more that's similar to this. Number 14. Number 14 on that same page of the PDF. Number 14 on the same page of the PDF. I'm going to write this one down. Number 14 gives you two pieces of information. Now, they don't tell you that it's arithmetic. They don't tell you, I'm sorry, let me rephrase. With number 14, they tell you these two terms, but the only evidence that you have that this is arithmetic, the only evidence that you have is in the directions, I should specify. But these are the only two pieces of information you have. So what are your options? Here's one option right here. Okay. Fourth term, fifth, sixth, seventh, eighth, ninth, 10th term. I know the 10th term is 48, and I know the 8th term is, or the 4th term is 18. I think I can figure out a common difference here. Okay, like if I added the same, you guys could probably guess and check what this common difference should actually be. You could totally guess and check what this common difference should be. Actually, I already got it in my head. Anyone know what the common difference is off the top of their heads? Because it actually is quite simple once I tell you the little trick that I have in mind. But I'm not telling you the trick just yet. It's basically like if it's arithmetic, they're going to be adding or subtracting the same number every single time. They tell you it's arithmetic. It goes from 18 to 48. It should be plus 5. Can you tell me how you got that so quickly? You just kind of looked at it and you're like, well, if I added 5, it would get there, right? Do you know an easier way of doing it? Slope. How do you calculate slope? Same exact thing. It's literally the same exact thing. Arithmetic sequences are nothing more than linear. They're linear. And your common difference is your slope. So instead of having to, yes, when I wrote that out, you're like, well, I just looked at it. Yes, absolutely. But what if I gave you the 4th term and like the 200th term? That would be a little difficult to look at. Oh my word. But as I talked about last time, arithmetic sequences are nothing more than linear. And since arithmetic sequences are linear, I can calculate my common difference or my slope by doing the following calculation. Change of y over change of x, or y2 minus y1 over x2 minus x1, or the difference in the term values divided by the difference of the term numbers. It's a little weird to think of it like that. 30 over 6 gives you 5. 5 is the common difference. It's slope. It's nothing more than slope, which is really nice. Once you realize that it's slope, you're like, oh crap, that thing that we've been doing since like 6th or 7th grade? Yeah, it's back. That's one piece of the puzzle. One piece of the puzzle is finding that common difference. The second piece to the puzzle, I still need my first term. Now, I'm actually going to take a little bit of a shortcut here. Because I know that my 4th term is 18, and I know that it's adding 5 every time, I'm just going to work backwards. If I have to work backwards, I'm going to subtract 5 every time. Meaning my 3rd term would be 13, my 2nd term would be 8, and my 1st term should be 3. And it is. It's so close, why not take the shortcut? If you're that close, take the shortcut. Before, on the previous problem, I was 12 terms away, and I didn't feel like taking the shortcut there, although it wasn't really a shortcut. But if you're only like 3 terms away from the first term, go for it. Go for it. I'm going to write the rule now. A sub n equals the first term plus parentheses n minus 1 times the common difference equals 3 plus 5n minus 5. My general rule is now 5n minus 2. That's the general rule. That is the general rule. It's an amazing piece of math. So now, I have something exciting. I have something incredibly exciting that's really going to mess with your heads a little bit and bring back some PTSD moments from algebra. It really is. You know, what's really funny, though, is you guys in the class here, you guys that are actually present here, I did not teach you Algebra 2. But it actually turns out that the people in the chat, I believe I did teach them all Algebra 2. Weird how that turns out. All right, let's write down, not that one. Let's do that one, number 20. Let's do number 20. Yeah, let's do number 20. On that same page, number 20. Check this junk out. This is amazing. This is what we call a series. A series is nothing more than a sequence that is being added together. That's all that it is. A series is a sequence, but it's all being added together. That's all, the only difference between the two. And now for these two parts, for part A, I should say, they actually want you to find the sum of the first, they say n equals 15, so 15 terms. They want you to find the sum of the first 15 terms. Now, this isn't so bad, really. 15 terms is not that bad. I could easily find out all 15 terms and just add them up by hand. I can see that the pattern is plus 10 every time. So I would just be like, okay, 25 plus 35 plus 45. So it's 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There we go. I got my answer. What I just did is not practical. What I just did is not practical. It works, but what if instead of the first 15 terms, I asked you to add up the first 90 terms? Or I asked you to add up the first 1,000 terms? That would not be practical to do it this way. So I'm going to find a different way to do it. A faster way, an easier way, a quicker way, a more efficient way to get that answer of 1425. And it utilizes that formula, S sub n equals n parentheses a sub 1 plus a sub n divided by 2. It's going to use that summation formula. That summation formula is specific to arithmetic sequences, and this is indeed an arithmetic sequence. There are certain pieces of information that I automatically have. Let me plug in some information. First of all, they want me to find the sum of the first 15 terms. Notice what I just wrote down there, S sub 15. Because they want the sum of those terms, all 15 of them, from the first term up to the 15th term. So instead of n, I'm going to put a 15 out front of those parentheses. Because, well, that's what n is in this case. On the top of that fraction, they say a sub 1 plus a sub n. Well, I know what a sub 1 is. A sub 1 is 25. Ooh, what is a sub n? I'm going to put a 2 on the bottom. There we go. That 2 always goes there. A sub n, in this case, a sub n should be equal to the 15th term. Now, I did that on the calculator. I know what the calculator says the 15th term is because I did it by brute force. But if you just wanted to figure out what the 15th term was, you could do a little side note right here of a sub 15. If you did a little side note of a sub 15, you could be like, okay, well, a sub 15 is the first term plus parentheses n minus 1 times the common difference. Look what I just wrote in there. Oh, you can't see all of it. Look what I just wrote in there. I'm going to zoom in on this. Zooming in right there. Move that up to the top. The 15th term is equal to a sub 1. Notice I didn't write a sub 1, but a sub 1 plus n minus 1 times d. And instead of the n and the d, I put in the proper numbers. If I did that calculation, I'm going to do it right here. 25 plus 14 times 10, that's 165. 165 is the 15th term. It's the 15th term. It's my a sub 15. That is what's supposed to go in for this spot right here. A sub n in this problem is a sub 15, which is 165. These are the puzzle pieces that I'm talking about. These are the different components that they technically don't give you, but you can seek out these components and then put them together to solve the puzzle. That's all that math really is just one giant puzzle. Some people hate puzzles. I love puzzles. So I'm going to do this calculation very carefully. 25 plus 165 divided by 2 times 15. On my calculator, it says 1425, which I did know that was the answer by brute force. I did know that that was the answer by brute force by just adding up the first 15 terms, but it's more efficient and more practical to do it this way. It is more efficient and more practical to do it this way. Find the sum of the first 15 terms. Okay, I can do that. Now it is time. What is this? Oh, that's weird. Okay, get rid of that. There we go. Now it is time to show you where those algebra skills have been leading up to. Because I still have to do part B. Part B of that problem. This is, in my opinion, the absolute best part of this problem. It is the absolute best part of this problem. They say in the directions, find n for the given sum. Find n for the given sum. And they tell you the S sub n is equal to 3105. For the same series, it's 25 plus 35 plus 45 plus dot, 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 dot. That's what they're doing. But they want you to basically do the following. How many terms did they add to get 3105? That's the real question. That is the real question to this problem. How many terms did they add up to get 3105? What is the value of n? How many terms did they add? That is the question. That is what I need you to wrap your minds around. Find n for the given sum. Here's what we're going to set up. We know it's arithmetic, so we use that arithmetic sum formula. 3105 equals. We don't know what n is. So we're going to leave it there. It's supposed to be in the fraction. A sub 1 plus a sub n. It's supposed to be a sub 1 plus a sub n. Well, I know what a sub 1 is, but I have no idea what a sub n is. Oh, wait. A sub n? A sub n. A sub n is supposed to be the following calculation. Let me do a little side note over here. Let me do myself a little favor and do a little side note over here. A sub n equals this formula. Let me do a little side note right here, and then I'm going to have to come back to that problem. A sub n is that formula. A sub n would be the first term plus n minus 1 times the common difference. The same formula that we've been doing over and over and over again. I'm going to distribute that 10, and I'm going to get A sub n equals 10n plus 15. Let me leave that up there for a moment. That's what we've basically been doing all day with this problem. Holy crap, that's what we've been doing all day with this problem. Just as a side note, this actually will be the last problem that we do today because we need to, this problem is a biggie. This problem is an amazing problem. But again, I bring your attention to the fact A sub n equals this formula, this rule, this equation. And since A sub n equals that equation, that is what's going to be plugged in to the blank in this equation right here. 10n plus 15. That formula is what is needed for this problem. And now all of a sudden, this thing is going to blow up like crazy. This thing is going to get nuts in a moment. Absolutely stinking nuts. So, I'm going to have to maneuver some things around. First, the absolute easiest way to deal with this divided by 2 is to multiply both sides by 2. If you multiply both sides by 2, that'll move that 2 over to the other side of the problem, and it will get rid of your fraction. I'm going to do that. If you multiply both sides by 2, you end up with the following calculation. Now, notice again for a moment that I actually also simplified the inside of that fraction. I simplified it by taking the 25 plus the 15, and I just simplified it together. Again, I need you to think back to Algebra 2. I need you to think back to Algebra 2, because look what just happened. If I were to distribute that n, I end up with the following equation, and this is what I have to end up solving. This is messed up. This is completely messed up. Now, I'm going to ask simply because I don't know for you guys right here. I know for the people online, but I don't know for you guys in the classroom right here. Algebra 2. What method did you guys end up using for solving quadratics? Use the quad formula? Did you use anything else? Okay. What about, did you have a method for, now mind you, I know what my kids learned because I taught them, but did you have a method for factoring? Was it the Tucker method? Okay. Was it the method with like an X? Oh. Now I don't know what to think. Because you had Betty, right? Miss Cherry. Oh, Miss Cherry, doesn't she do the Tucker method? The Tucker method is the one with like the little T chart. All right, that's fine. It's been a minute. It's been a minute, right? Yeah, it's absolutely been a minute. Here's the thing. My job is not to reteach you how to solve quadratics like this. That's not my job right now. My job is not to reteach you how to factor. I want you to do this in the easiest way possible. That's honestly what I want. And the most efficient way of getting this particular problem done the absolute most efficient way of getting this problem done would be using the quadratic formula, which again would be given to you. I mean, technically, this is factorable. This is totally factorable. And if you remember how to factor quadratics, you can factor this thing and get the answer done in no time. But again, I'm not trying to reteach factoring. I would like to pretty much go straight to the answer. The fastest way to go to the answer is the quadratic formula. I guarantee you, if you're doing it correctly, then the quadratic formula should spit out nice answers. It should spit out nice answers. So I'm just going to rewrite the quad formula right here as a reminder as to what the quad formula was. The quad formula that you learned in Algebra 2 is something that I would give you to solve this. To solve quadratics. To solve quadratics, you're going to need this quadratic formula. Like I said, if you remember how to factor, you could totally factor, but my job right now is not to reteach you how to factor. I don't want to take, well, not that I don't want to take the time, but I don't have the time in the school year to reteach you guys how to factor. So I'm just going to say, let's brute force it into the quad formula. But like I said, it can be done otherwise. So in terms of A, B, and C, A, B, and C, A would be the 10, B would be the 40, and C would be the negative 6210. You can plug in that information where it belongs. Negative 40 plus or minus the square root of 40 squared minus 4 times A times C. I'm going to have the calculator do most of this for me in a moment. The whole thing is over 2 times A. The calculator is going to get most of that done for you. You just have to know where to plug that junk in. You just have to know where to plug that junk in. Let me zoom in a little bit more down there. If I plug in that information approximately where it's supposed to go, and I have the calculator do it for me, 40 squared minus 4 times 10 times negative 6210. Yeah, 6210. Inside of that square root, here, I'll show you right here, actually. Inside of that square root, I get this calculation. I'm going to have to do the square root of that number, which is nice. So I end up with negative 40 plus or minus 500 over 20. If you were to solve for the plus and the minus, I'll show you right here what you should be getting on my calculator. Technically, we get two answers. You get a positive 23 and you get a negative 27, but that negative 27 cannot be your answer. You can't have a negative number of terms. So the answer does have to be 23. Unfortunately, this is the process that has to happen to get this thing done. I am going to look for a nice and easy way to solve quadratics. Better than this, really. In fact, I would hope that you would be able to just simplify the quadratic and possibly use an online tool to just knock out the rest of the quadratic, and that would be wonderful. That would be absolutely wonderful if we could do that. But unfortunately, using quadratics is what is needed for this problem. You have to use quadratics on this problem. It's a pain, but we have to do it that way. Like I said, of course you could factor that thing if you wanted to, but again, I'm not going to reteach you factoring, especially considering like I don't know what Cherry taught you. You know, I have no idea. So I'm not going to reteach that. Silly. Okay. This was a lot of arithmetic. We did arithmetic, all stinking class period. Let me just recap what we've done today with arithmetic. I wrote down these 4 formulas at the beginning, but we've really only focused on these 2 today. These are the only 2 that we focused on today, these 2 formulas for arithmetic. Next class, I'm going to focus solely on geometric. But we were able to solve various problems using that particular arithmetic formula for the general rule. We were able to find the puzzle pieces and fit them together in order to solve for certain terms. We were able to equate arithmetic sequences to linear relationships to find slope. We were able to use that sum of the formula in order to find the sum of any number of terms we want. And then ultimately, quadratics rear their ugly head. But like I said, I'm going to try and find an online resource to be able to solve this quadratic so you don't have to actually worry about typing that out, because that's not the purpose of this. The purpose of this is you utilizing these formulas and utilizing these formulas correctly. And if you can utilize these formulas correctly, I think that it would be beneficial if we could just use an online resource to solve those quadratics. I think that that would be beneficial. Okay. The time is approximately 8:18 or 8:19, something along those lines. The class period ends in about a minute or 2 minutes. I think it's 2 minutes. It ends in about 2 minutes. I'm going to remind you that you have been working on a project for me. This project I originally assigned to you on May 13th, which was Thursday of last week. And I made that project due for Friday of this week. If you do have any questions in regards to it, make sure that you are contacting me. I can see, based on the student work on Google Cloud, I do have some work completed by some people. So like I said, I mean, obviously it hasn't been submitted yet, but if you do have any questions in regards to that project, please make sure that you are contacting me. That would be phenomenal. Yeah. What time is that thing due on Friday? I think I made it due for 7:30. Yes, I did. Okay. Now, like I said, I have it due for 7:30, and I probably should make the change now. I was going to say, like, if you don't have the project in by 7:30, but you have it in by the end of the day, that would be sufficient for me, or the end of the school day, I should say. So I'm actually going to make that change now to it. I'm going to make the change from 7:30 to the end of the school day, which would be 2 p.m. for me. I'm going to make that change now before I forget, because I want people to get that project in. And I want to make sure that you have the time to do it. So I am giving you just slightly more time to do that. Otherwise, if you have not left a comment in the chat, please make sure that you do so. I do see the 3 of you that have left a comment so far. And the class period is going to end in about 10 seconds. So I'm going to sign off on the stream. Huzzah! Oh, Wednesdays. You and your Wednesday ways.